Okay, last time we already looked into components of computer. Basic thing about the technologies name uh, for personal computer, for the mainframe, and all of this will be continuous later on for your next semester. Next semester you're going to take OS, operating system. So this subject will be continuous. That's why you need it's good for you to have basic, because everything will be continuous. If you think that okay, I will focus my study next semester because this semester I think I cannot manage to focus, I cannot manage to score. But if you cannot understand the basic from COA subject, you cannot score in your OS, operating system subject, because everything here, this one, the name of the function, the structure here, most of that will be repeated to your COA subjects. So this uh, system, we already looked into our previous class. I hope that you still remember you need these four component in your system. If not, if let's say you don't have one, so this will be a collapsed system. You cannot have a one full system. So you need to have input, output, and process. This is the first important thing. But sometimes for the processing, for the input, you need also a storage before you can proceed to the output. And the most famous, or might be always repeated question from every semester is the brand of the computer. So mostly there will be one question for MCQ at your might be test 1 or might be for your final exam. What is the brand component for a computer? So you need to know what is it. Processor, what we call a processor. Last time we see processor, there will be 3 part. Okay, there will be 3 part under our processor. Muhammad Hatim, what is the 3 component for processor? Muhammad Hatim? Kenapa saya tak boleh remove dia? Okay, next person. Tiba-tiba semua pasang webcam pula. Gan Jiahui. You use 2 devices? I punya speaker bunyi ke tidak? Kenapa tak ada suara? Gan Jiahui. Okay. Can you answer me? What is the 3 component? For the processor? Yeah, the processor. What is the three component for processor? Last week we already go through. There will be a three component for processor. Actually, it's going to be four. Uh, no, the processor. Under processor, it will be three part. What the three main part in your processor? Okay, thank you. Amira Azkia.
Yes, doctor.
Uh, what is the two component for storage? I repeat the question. What is the two components under storage? You all tak ni tak buka nota sekali I rasa the question is direct. It is on your notes. I already provide you with the notes and you also already learned it previously in our previous class. Kawan you yang kena keep ni dia tak nak masuk balik ke? I was typing in the chat. Did you remove me? Next time, I don't know how he can join again or not. Amira, can you answer? Under storage, there will be two components.
Is it? It's not the CU and I input output, right? Pretty sure it's not that.
No. Under storage, there will be two things there.
Not sure. I just woke up and it's 3 a.m.
Okay, it's okay. Thank you. At least you respond me. Please make sure you enable your webcam, okay?
My Wi-Fi is pretty bad, so I might get disconnected if I turn on my cam all the time. That's why I have it off.
Okay, this one is things that we already been through last week. You can see here, this diagram I already mentioned to all of you. How to spot a question. I give you several types of question that can be asked, which is related to definition. Some of it, it's easy for us as a lecturer to find definition as a question. Especially like these kind of things, you have four definition here, six. We just normally swap the definition. Might be I put a powerful here. If you still remember previous class, I talked about powerful because last semester I did the question. A powerful device. So might be you can have the option workstation and mainframe because it having a powerful keyword. But for mainframe, it is multi-user. For the workstation, it is single user. That the only different. So if you just powerful, that came in your mind might be mainframe, so you're going to pick the wrong question. So just a simple that we can ask you a question for multiple choice. Similar also, I ask you every single diagram, when you look, okay, you can categorize it into 3. Okay, under processor, you can categorize it another part. So this is our favorite things to ask question. I can give you multiple questions like, okay, which is the incorrect component for computer? So I give processor, A for processor, B for storage. Wait. Okay, I give you a question. Which is incorrect for computer components? So I give A processor, B storage, C might be I put input, D will be apa a wrong question here, a wrong answer. So this is easy for us to ask you a question. That's why I said important. So don't wait until another 2 weeks from now it will be test 1. So you want to read and go through. After each class or maybe in the class, please make sure you understand it carefully. Okay, I already give you a hint. It must be a come out a question from this kind of things, which is you have a diagram. It can be also asked, which is incorrect component for processor? Because it's easy for us to have A, B, C there. Over here also, select what is the storage component. We can give you several things. Maybe I put here USB. I put CD. So you need to tick which is correct. We didn't provide you with storage 2 component, no. But instead, we want you to pick by your own. Maybe you can pick 1 only. Maybe can you pick 2. Maybe you can pick 3. That's why it's easy. Again, I said easy for us to ask you a question when we have a diagram like this. Okay, so now, again, these things is important without you to have the knowledge of the basic system for a component. Then later on it's very hard for you to understand, because under process you have 3 parts. In this part, you can see here ALU. Later on, you're going to go deeper. CU, you're going to go deeper. Register, you're going to similar to all of this. So please make sure before you move to another subtopic, you need to remember and understand. Although it is just a second week for you, maybe you said, okay, I still not yet tuned for start my this new semester. Still, every subject, not only for COA, please make sure before you start your class, you prepare with your notes beside, so you are ready. Okay, over here we have processor, storage, and input output. So all together 4 things that you need to have under computer. But normally input output we're going to like combine together, like IO, input output. And processor, again, basically this is just a recap because we done go through last time in our previous class. We have ALU here, CU, and register. ALU, arithmetic logic unit. CU, control unit. Register is your register. You're going to have a lot of register type, EAX, EBX, I forgot. So later you're going to look into all of this, and you need to use your Visual Studio to see the value of your register. So that's why you need to try to use your Visual Studio also. Normally it's going to be some error before you can have the environment for you to start with the lab. Under storage, it will be main memory and secondary memory. For devices, it's very easy. You have the device, which is hardware. But instead of just a device, of course, you need to have an architecture of your input output. And again, I said last time, I can't draw, I think. Okay, this is the most beautiful draw that I can do for a human. Okay, as a human, we have heart. Again, I don't know how to draw. We have liver there. All of these might be, we can call it as a component. Input, storage, processor as a heart. And this is important, but you need to have the vents, isn't it? Your vent, which is salur darah you, we call is a system bus. System bus is the connector for all of this. Maybe you have a processor there. From your heart, it's connect to your liver. And then from your heart, it's connect to your, might be your hand, your brain there. So similar to your computer, without a connection, which is we call as a bus system, system interconnected, a bus system for our program and instruction, and also the data. So this is the basic processing needed. So now we go through on structure and function. What is the difference between structure? What is the difference between function? So structure, the way which component are interrelated, while for a function, the operation itself of your component as the part of the structure. So maybe you have our normal structure last in our government. We have prime minister, we have minister of whatever minister here. So education minister, we have another minister types. So we have the structure. Under minister, we have a lot of others. So this we call as a structure. Inside the structure, each of it got their function. Okay, what is the function of PM? What is the function of minister? So this is the differentiation between each other, similar to our computer also. Computer also have a structure, and each of the structure have the function. This is definitions of the computer. It is a complex system. This definition we have gone through last time in our previous class, with a hierarchy system, which is how to connect. You have the CPU, you have the storage. So it will be a structure from this to this. So you have the connection to each other, and each part they have their own function. So each level, you can see, you need to know that it will be having a structure and also a function. Your system computer can be divided into two main parts. Okay, if we have two here, it's quite hard for us to do a multiple choice, because we need to at least have A, B, C, D, which is 4 things. But sometimes we can have the tick one, which is the negative marking type of equation. We can have until like 5 or 6. So I guess this part or this part or even this part can be asked. It's quite easy for me to ask a question. Might be I can do a question like, okay, what is the, okay, pick or tick a correct component for structure. So I list memory, input, output. Suddenly I put data storage here. and then I put CPU, I put system interconnection. So this part is correct, this part is correct, but this one is wrong. See, the simple question just from the diagram, because it's quite easy for us to do a question. So that's why every diagram is very important for you in this subject, how to tackle. If you compare to the digital logic subject, you need to know in terms of technical, in terms of the method, how you need to memorize the rules, and then you need to apply into your CAMAP and etc. Right? But that one we can give you in terms of equation with any kind of equation for your Boolean expression, if you still remember. But for COS subject, everything will be asked from slide equation, which is direct. If you look into your digital logic subject, we give you a question which is not in the slide. I mean that might be you can see simplify this Boolean expression, which is A B dot B C. So you can see here, oh, sometimes this Boolean expression is not in your slide. So you need to think, but you will apply the technique of the simplification technique. But in COA subject, every question you need to memorize from slide, and it will come out from slide directly. So I guess it's very easy for you to score. We just directly ask you to answer all the things that you have learned directly from the slide. No need for you to like things beyond of all the slide here. But it's good for you to have a knowledge. You can go for Google, YouTube, learn more on like deeper for each structure, memory, input, output, and the rest. Okay. But here I just give you a hint, which is how to tackle the question and why. Just now I asked you a question in the beginning of our class, because every diagram, although it's just like a simple just a question like what is the component for CPU. So if you already remember, it's easy for you later on to tackle a question. Okay, this one also we already looked into in our previous class. You can see here, this is your communication line, similar to also peripherals, which is a connection to your computer. Under in your computer, you have the storage and processing, but all this connection will be connected to your input-output device. And under a structure, this is the things we are looking now. Under a structure, we can divide it into two parts, which is single processor computer, which is your traditional computer. I don't think that we have it now for our computer, but we are now using our multi-core computer structure, which is using parallel processing. So this is the single processor computer, how the architecture look like. Here is your main thing just now. The four things that you need to have: your main memory or your processor, and then you have the storage, you have the input, and you have the output. And again, as mentioned, although it is these four components that important, you need to have also a connection, which is a system bus here. One, which is storage, CPU is your processor, input here, output this one. So this is four components that important for computer, and you need to have the system bus, which is connect for all of these components. Now we look deeper on our CPU. We have ALU register control unit. Again, we have all these components inside. how to connect them. If we don't have a connection to each other to connect them, it cannot be happen as a computer. We cannot run it because there is no connection. So we have a system bus again, but we call it internal because it's in the CPU. So internal bus will connect the register to the ALU, will connect also with your control unit. Then inside your CU, okay, later you're going to look into inside ALU, inside register. But in this example here, we have the control unit. Inside a control unit, you have a sequential logic and control memory. And a connections is under a control unit register and decoder. So that is under your control unit. Another one more things that important for you to remember, you're going to find out there is a lot of table for your COA subject. From the beginning of module 1 until module 8, you will have more than 50, I guess, table. So each table is very important because that is the only things that we can ask. We cannot ask you scenario questions in the test and final exam. So what we will do is like we give you might be CPU, memory, input output, system connection. Okay, what which of these is incorrect task? Might be for memory, or might be I give you a list. This is the list of component and each task. Okay, which is incorrect? So I give CPU. The task is this. Memory, I give a task is this. But input output, I give task of mechanism, blah 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 blah. I just copy paste, okay, for the question. So just give you a different answer. So it will be a answer for your question. Just simple of that. That's why you need to memorize for this COA subject. Although you need to understand the task, but of course you need to memorize the table. If you did not know, then you cannot answer. Okay, so please tackle a question if you find diagram, a table, each of definition, and hierarchy, pyramid. I think like 2 or 3 pyramid you're going to find in our COA subject. So most of it very important. So CU, what is the function of CU? So CU will control, because it's going to be a man for you, a system, control the operations of the computer and perform processing. As you know, that will be a processor. So might be if you don't want to remember all the definition, so you need to know about the keyword. Okay. Next is your memory. You can see here under your memory, it is a store data. Input output is going to move data between your computer from your keyboard to your display. So that will be the task. And lastly, the system bus that it connected, help you to connect all the others component. It called as a mechanism for a communication. So you can see, if you have this, then you can communicate to each other. That is a mechanism for communication. Okay, there is also another one. Just now is CPU. So we go deeper under CPU. What is the task? ALU, it got their own task, which is perform computer data processing function. CU, control CPU operation. Register provide internal storage. That's why just now I inform you, later on you need to find the value of your register. So all of this you will find when you run your program at your Visual Studio. You will see the value here, and your value will be on hexadecimal. Okay, we will play around with hexadecimal, and mostly the answer here, no need for you to put H, because we know in COA subject we are playing around with hexadecimal value for your computer. So you need to know register will be a storage. It is not going to register whatever installer or function to your computer, but it is a storage, internal storage. And interconnection, you know, it is quite similar to your previous, the main bus here, communication. Okay, communication, but it is internal, means that connection for your ALU, CU, and a register. Please make sure you memorize all of these functions. Okay, storage computer structure. So this is under a structure. Normally a computer have a multiple processor. This is comparison between a single one. This is a single, right? Single. And now we are looking at the multi-core computer. So it have a multiple processor. And all these processor, although you have a lot of processor, but it is all inside in one single chip only. And all of these will be having a CU, ALU, and register. We call it as a core. A single core, double core, and etc. But it have many processor inside. The use of multi-layer memory is called as a cache memory. Later on, you will find there is another or many memories in your computer. Like a register is kind of one memory. Cache also another type of memory. Okay, this is your motherboard. That's why if your motherboard is like burn, there is a short wires in your computer. If you it's affect your motherboard, it's going to be quite expensive because it is the main of your computer. There will be a main memory chips. It's going to have the input output chips. And here is the things that we want to look into, which is our processor chips. In our processor chip, one processor, we have several cores sometimes. You can see here. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 core inside this one single processor. And we have also a cache, which is another type of memory. In single core, we need to have all the function, ALU, instruction logic, load, and the cache itself, but it is an internal data cache, not this cache, okay? And the structure of all the cache. This is under structure, and now you can see we need to have, we already cover on the structure. Now we're going to move on the functions on the sister computer. For function, board structure functioning of a computer, very simple. Although it's as simple as you open your computer and then suddenly you can see the display. But on top of this, you can see, oh, now it's very complicated. But actually, it is simple as for the function. there will be terms, general terms, which is under function. First is data processing, data storage, data movement, and control. If you look into previous test 1, all of these questions will be coming out from this table. It just give you a simple, just now like I mentioned, which is incorrect, which one is correct. So we just wipe the definitions. Might be we can ask you a question like this. Okay, what is the task for data movement? I give you only like move data between computer and or might be I change this one, might be inside a computer only, between computer only. So it will be a wrong statement because it need to also have a correlation between a outside. So just a simple like that, I can give you a question from this table. So for each task here, you can see data processing is under process data in variety of form and requirement. Data storage is short and long-term data storage. Data movement, it moves data between computer and outside world. And lastly, your control. Control will control the process, move, and store data using the instruction. Okay, before we go to the another step, another subtopic, let we have a break, 5 minutes. You can go to your ladies toilet. Maybe you can go and pick water or some refreshment. Okay, so we stop and start again another 5 minutes, 6 minutes. Okay.
Doctor, I think you forget to unmute your mic.
Okay, sorry. Okay, let we continue. Just now, I asked you to scan also. You can't hear. Okay, please scan your QR code first for those who still not yet scanned. And we're going to continue our class. Please enable your webcam and we will proceed and continue with our class. Okay, I want to open the one of the example program just now. Okay, this is example of one program. So it will be chicken. Okay, you can see here under our program is a sequence step. So this is example of sequence step by step. Okay, the program that you're going to develop is going to have for each program or operation here, you're going to put okay, this is operation of move, this is operation of adding. Only these two operations that you have, but you're going to have several steps, and every operations you're going to have like a unique code for them, like adding, move, you're going to have like MOV only. Adding, you're going to have add, subtraction is going to SUB. So that will be under, we learn on assembly language. Okay, so this is all assembly language. Under one program, you as a programmer, you need to create this program. Might be going to create calculator for the program of a calculator. So how you going to create? So here under your Visual Studio, I think I need to make it bigger because most of you will see it's quite small. Okay, under this one, you can have what is called step by step, a sequence of steps. Let's say for this program, you can have, of course, going to start pointing at the first after your .code code. So it will start from here. Okay, main program, and then you have what? Your operation, first operation. So from here to another. So it first will be looking into move EAX. Just now I mentioned to you EAX is register. Means that you're going to have 10,000. So again, you can see we are using a hexadecimal. Hash is a unit for hexadecimal, and this is normal value, but in hexa. 10,000 hexa. So in your output later on, you're going to see in your register EAX, it will be having the value of 10,000 hexadecimal for this move EAX. So single sequence will be sequence of step, step by step. Later you will see there is also a function for you to do step over or step by step. We can see step over. Kenapa tak boleh tutup? Banyaknya saya buka. Okay, so when you going to have a step over, you have also a function for you to step over, and then you can do a step over. You can see here there is a pointer for you, and this is all program. It will be step from one step to another by just pressing your F10 at your computer, at your keyboard. So you can point to another. So it will be having a step sequence for your computer, and each of it having a operation. This is the operations. Add, sub, call, whatever we have mentioned is as a operation. What else? For each operation, a different or new set control is needed, and it will be a unique code, which is we call as instruction. Okay, this is instruction for your operation. Means that, mana I pilih conteng? Tak boleh. Okay, means that when you have operation for the single line here, like operation, my operation now is move. I want to move the value of naik. Kenapa dia turun? Okay, I want to move the value of might be 50 hexadecimal. I want to put it into my storage under my register EAX. I want to put here. So I need to come up with instruction. With instruction for my operation here. My operation is what? I want to move the 50 hexadecimal, 50 hexa to my EAX. Move EAX 50 hexadecimal. So it called as instruction, and it is a unique code. This one is unique. Sometimes you can see this is the full MOVE, but this unique instruction called as MOV only for your assembly language. And you can see a bit and slightly different here. We want to move 50 hexadecimal to EAX. But in your program, you can see here in your program in single line, because you have a program, right? There is a lot of other lines there, but one single line, you can see it will be move. Normally in your sentences, it will be like, oh, move EAX to here. No, this will be your destination. This will be your source. Okay, source and destination means that you're going to move this to here. It's slightly macam switches terbalik sikit from here to here. But that is how you're going to write your programming. That is this example. You can see, move this to here. Then at the answer here, you're going to see F10. I close my output. Where is my output? Just now I close all the windows. I need to enable it, and I already forget how to enable. Wait, output. It is supposed here. Okay, let me step over again. Another step over. Now I'm here. We don't have any output yet because we just point here. When we point here means that we just finish line before it. Try to another step over. Then we already have finished the single line, and we will continue with another line and I want to find where is my output. Okay. Register. Okay, this one. You can see here, I hope that you can see the example. Okay. When I point here, I click my F10. I point here means that is not the answer for here, but I just finished my line, previous line. So the answer will be EAX 10000H. Normally, it's not going to put H at the back because we know in our register all is hexadecimal. So this is value for my EAX. I hope that you can see. Let me check my setting. I make it more bigger. So this is my EAX. You can see the value. And I try to doing another step over. I point now at the line 11. Means that, what does it mean? I already finished the previous line. This is the functions or a program operation for adding. Means that firstly I have here where is pen? Okay. Just now I have EAX equal to 10000 hexadecimal, right? First at the line this. At this line, I already finished and it will be valued. And now my second, after I point here, I finish adding. It asks you to adding from the source here. You can see here, my source, I'm going to add 40000 hexadecimal. You can see here. And where I'm going to add? I'm going to add destination is my EAX. Means that I'm going to add this value with my EAX. So I will add here. I will get 50,000 hexadecimal. That's why after you finish this single line, you can see the answer is 000050000 hexadecimal. Why it's like this? Because in our register, we're going to have 8 bit. 1, 2, 3, 4, 5, 6, 7, 8. Remember, this one is quite similar to your digital logic. Okay, you have 8 bits altogether. That's why in front here, you're going to have also, later on, you will learn about the size, okay? Size of your register. So that's why you're going to know that EAX will be having 8 bits. And if you have AX only, how many bits that you're going to have, and etc. Okay. What else? Okay, this is one step. Let's say we point another step. Okay, now I point to here. You can see my EAX already changed. Okay, my EAX already changed. You can see here it's already T0000. Why? Because I just finished this line. What this line require me to do? It asks me to sub. Sub mean subtract. You need to deduct. How many? 20000. With this one is source. Destination is what? EAX again. So I need to see my current value of EAX, which is 50000 just now. So I need to deduct with this value. What I will get T000 hexa. So you can see this is the value for my AXM. That is what you're going to do in your lab later on. And in your test also, it will always ask you in terms of this. You need to find the answer and etc. But how to relate with our module 1 here is on the operation that available in the program. I show you this is all one program. You have a lot of line here, and in each program you have a sequence of step. Each step a computer function will be execute, means that each step we're going to get the output, and it will be having operation. Each operation having a unit instruction and a hardware segment accept the code issues of the control signal. Sometimes you're going to relate with your output later on for your display, which is related to your hardware. Okay, let me proceed with our module. Now we have the program executions. So when you try to execute, okay, just now dah tutup dah tak apa. When you execute your program, what will happen? There will be two approach, which is how to execute. You're going to do hardware and software. This is also quite a favorite question for us to ask you in a test, which is what the difference between hardware and software. Sometimes it's going to be looking into the speed. You're going to see here. Okay, hardware is provide high speed, but software is less speed. Why? So it is easily reprogram. And if it is high speed, but it's inflexible to change because it already have like hardware already that already installed in your computer, which is related to wired. This one software related to your program. And for hardwire, you're going to use arithmetic and logic function like these logic things. That's why you're going to have like connection and etc. But instead of software, you're just using a code, instruction code. But you need to have the interpreter, which is to speak with your machines. You're going to learn that you need assembler for you to communicate with your machines to change it to the machine language. C programming, Java, Python, and etc. also need something to change to the machine language, because whenever you writing your programming, it's quite complicated, but computer only know 101010, that is the machine language. That's why you need to have the interpreter. You will learn in your next module. Here is hardware and software approach. Programming in hardware and programming in software. When you already have program in hardware, it's very hard for you to change. And for the programming in software, it's easy for you to modify it later on, but it's more slower compared to the hardware. So how is connections look like? How the connections look like from data that you are input. You have a sequential arithmetic and logic functions, and you're going to have the result for your display. While for the programming, you need to enter a code. You need to have these things. That's why it's very important for you to have the interpreter before you have the similar thing what is here. Quite similar because you have the arithmetic and logic function before you get the result. And finish about your theory. We look into history. History on your evolvence computer. It's rarely for us to ask you history subject or history question. Might be what is the technology on 1965? That will be not going to be happen because we are not history subject. But this is your knowledge for you to know the evolutions of a computer. So I'm not going to touch it more deeper. You can go through and might be you like to know history about computer, how the evolutions of computer. Okay, this is your first versions of computer. Okay, this one is important. Although it is history, but you need to know this is the first version's name, which is called as von Neumann model. Okay, pronunciation is von Neumann. So you can try to look into how to pronounce it clearly. And this is our first gen. The earliest of electronic computer, but although we call it electronic, but this, you can see it's quite big, like a machines, isn't it? So this is our first generation. And the first generations of computer, no layer architecture exists. So programming a computer was much of it of electrical engineering. That's why you can see like it's quite a big machines there. And all the program was stored store program computer has come to know as a von Neumann system using the similar name von Neumann's architecture, which is the model. This one is quite favorite for us to ask you a question, especially on the three characteristics under von Neumann model, which is built on the vacuum tube computer. So you need to know that the computer consists of 4, see, subsystem. Although I said you memory, ALU, control unit, input output is important, but you need to have also the connection to each other, which is your bus system. Program is stored in memory using execution, and lastly, programs instruction are executed sequentially. Okay, this is the structure, example of the structure. You have the main memory here and input output, which is totally quite similar, and you have a processor. But you can see, oh, where is your storage? Because you can see like okay, memory is a storage. Okay, you can see here the connection to each other. You need to have a system bus also. And these connections are from your input output. And then you have a storage, your processor. So it's also having these 4 elements that very important to each other. This is your main memory. This is your CPU. Quite similar, right? And this is your input and also output. Although it's quite, you see, why it look like quite different, but it is basically similar. This is a processor. Inside this, there is a arithmetic unit and control unit. I think there is no registers that's pointing up there. It is totally on the main memory. Conventional store program computer have undergone many increment process, which is year by year, similar to us. Currently, there is a lot of others new computer version, but mostly we are using still similar in terms of the system compared to the previous one, starting from the von Neumann. Okay, this is the still under von Neumann, which is first generations. Adding processor and parallel processing are example approach in your Vienna model. So you're going to add the processor to increase the computations throughput. And parallel computer improve speed. That's why we are using currently a parallel computer to do a multitask. If you didn't have the parallel computer, you can only open one task at one time. Okay. This is not the previous von Neumann, but it is a modified versions by adding the system bus. So that is why I mentioned system bus is very important for you to connect to each other. Although it's not drawing like this, but you can see here CPU still can connect to memory. It also can connect to input output. Your CPU also can connect using your address bus to the memory and then to the input output, depending on what type of process or program that you are dealing. Maybe you just dealing about data changing to each other, or might be you going to use your addresses. Addresses is very important in COA subject because you're going to have a lot of playing around with addresses. If you don't know how to calculate each address, also is going to be critical later on, because one single EAX might be register, you have how many address inside. Okay, and also in terms of program on the control bus, how you're going to control for each other. Okay, this is how the evolution of processor. Now we have a parallel processing. Later on you will learn HPC subject, high performance processing, in your year 3. And this is our microprocessor, how it look like, very small chip, but it contains several processors, CPU component in one single chip there. And about the Intel processor, might be this slide is not updated. You can try to find how it's look like from previous chips we have until the current versions. Because over here until quad 4 only, quad core only, you can see here Intel Pentium 4, Intel Pentium 2. This is the latest that shows in the slide, but I believe that there is a new versions. You can try to Google and look into how the chips look like. And this table also, although it's look like a table, but again I mentioned we didn't ask you history subject. This is just your knowledge in terms of the years and etc. As long as you know, there is a evolutions in terms of from one to another, is will going to increase, especially in terms of memory, the cache speed, the clock speed, the cache size, and etc. So it's going to be evolves. You can see there, right? And that is in terms of the evolutions of your computer and also processor. Now we look into the computer level hierarchy, which is you're going to have a lot of chips, your devices there, your cash and extra. So before computer can do anything, you need to have a software similar to all your keyboard, mouse, everything's need a software before you can evolve them to be one single hardware. So writing a program is quite complex when you are dealing with a complex function. So this level of virtual machine is very important for you. Again, you can see it's quite like a hierarchy, and you will find out this kind of things several times later on, but in terms of different functions, different layer. But this one is important. You need to know each level. Level 4 is what? Assembly language. What is the functions? Oh, to assemble a code. Control. What is the things under control? It is a microcode or hardware. We just will pick like very simple things for us to ask you a question from here. Maybe I will give level 3 is a machine, and it is for operating system library code. So of course you know it is wrong. That's why you need to memorize. So most of the time you need to memorize, and rarely you're going to apply. Okay, but you will apply your programming later on for the labs, in the code, in the programming. But most of it you need to memorize. So each level you're going to see from 0 to 6 altogether, 7 level. You need to know what is level 0, what is level 3, until the rest of level. And here is the table for you to see all the function for each level. Okay, I'm not going to touch it in deep. And this is the last things under our module 1, which is normal things that you will see on the advertisement. When you want to buy a laptop or a computer, you will bumping into advertisements like this. Kita panggil catalogs of a computer. What available for a single computer that we want to buy. So normally we will look into the what type of RAM that available, how much that speeds that we have, what type of the processor. Okay, well, let's take a look into all of this. Might be before this, if you don't have any background in computing, of course you don't know all of this. Normally you just look into storage. As big as it can be, then you will say it is good computer. But now you know processor is also important. And what is L1 cache, what is PCI, what is megahertz, what is MB, what USB. So without having the terminology understanding, you cannot understand it. So this is the measurement that we always apply. You can see here millisecond, kilobyte, megahertz. So all of this is here, and you also learn it in your digital logic subject last time, but I think not until here, right? Not until here. Last time you until tera and pico, but here you have peta and femto, which is, don't confuse with this. Pico is small letter, peta is capital letter. Okay? Don't confuse with that. And we have peta for 10 to the power of 15, while femto is 10 to the power of minus 15. Why I just pointing out to this, because all of others you already learn in your mathematical and also digital logic subject. Please make sure you remember and know how to convert it. Because there is a simple 1 or 2 question, we'll be asking only for you to having this kind of question. You will given with some value, and then what is the correct one. So you just need to convert. Similar also the simple versions of question about frequency. You learned it in your physics last time under like I think form 4. Form 4, we have frequency 1 over clocks, isn't it? Then you were given with the value. This one also in your digital logic subject will be already been true. So just a simple question like this, you need to know on the units. Okay, this one you can try to do. I think it's very simple. Similar also to the frequency, how you can get the cycle time. Maybe you were given with the frequency, you need to find the cycle time, or maybe you were given with cycle time, you need to find the frequency. Okay, let's take a look back at the advertisement here. You can see here, this is the microprocessor, which is the brain of the system. It execute program instructions, and now here it is under Pentium 3 667 megahertz. Next, we have our system bus. This is our system bus when we are dealing with this memory. It move data within a computer. The faster the bus, the faster you can get, and it's better for your computer. And the value here is 133 megahertz. Computer with large main memory capacity can run larger program and in high speed compared to the small memory. So RAM, you can see here, RAM, which is RAM, is a acronym for random access memory, that the memory content can be accessed directly if you know the locations. And now about the cache, your friend asked about the L1, L2, L3. You're going to learn it deeper later on, because we have several levels of cache. It is a temporary memory that can be accessed, which is much more faster than RAM, because later you will learn on hierarchy. Where will be your RAM, where will be your cache, where will be your register. The much nearest them to the CPU, the much faster that you can achieve on the memory. Next, we have this system has 64 megahertz, which of fast, which is synchronized dynamic RAM. And we have two cache here. L1 level 1 cache, which is smaller and probably faster than L2 because it's quite smaller and it's more nearest to your CPU. Note that these cache size are measured in kilobyte. You can see here. In terms of hard disk capacity, you have 30 gigabyte storage, and you have rotation D speeds 1200 RPM. Here you have the EIDE. What else you have? You have the CD store. I guess this one is old version. That's why you have the CD-ROM here. We didn't find this anymore in our computer now, the latest computer. You can look into this. And this is about your port. This one is important. Sometimes you even don't know. Last time, I just know the RS232 port that we have at our computer, which is this one, when I do PSM. If not, I just know it as a normal port that available and I rarely use it. Okay, this is a serial port. You need to know that is a send data as a series, and it's going to have a pass along 1 or 2 data line. You can find the technologies, a scientific name for this port also. It called as RS232, but we call it normally in a serial port. This is a parallel port. It's quite bigger. I don't think that we have in our computer. USB, this one is very easy for you. And back to the advertisements, you can see you have a system bus also, and also your PCI, which is a peripheral component interface. Okay, that's all about your module 1. Please make sure you try to remember the most important point that I mentioned, especially about the diagram, about the table. If you have any question, you can ask now. Any question? I don't like this look. It's too big for me.
Oh yeah, about that, Doctor.
Yeah.
Actually, you can change the size of your code inside Visual Studio without needing to change all your operating system scaling.
Where is it?
If you look to the bottom left above the word register.
Okay.
Bottom left. Yeah, here you will find above a little bit. No, above. Yeah, here there is a percentage.
Where is the percentage?
Above register.
Oh, okay, here.
Oh no, not this one, not this one. Above.
This one.
Yeah, this one. Yeah. Yeah, it will make it bigger actually. Yeah, now we see every single thing.
I never do this before. Okay, thank you.
Welcome. I used Visual Studio for C++ back in Programming Technique 1, and this was very helpful when presenting.
Yeah, I just use this for the COS subject. That's why it's rarely for me to use. I just run it every single of the lab. Then a simple programming, isn't it?
Yeah.
Okay, any other question related to might be your Visual Studio or might be in terms of your module 1? I guess if there is no question, please make sure you scan your QR code already. If not, you need to ask me because I'm not going to upload your QR code in your e-learning. So thank you everyone. We will meet again, right? Wednesday, isn't it? Aduh. So for now, take care because most of my students mentions they got positive COVID and extra. Don't go everywhere. Jangan pergi merayau-rayau. Take care and goodbye. Assalamualaikum.
Thank you, Doctor. Take care.